Persona never again.
Describe three classifications of robot applications. Robot operations can primarily be classified in one of three ways: material handling, assembly, and finishing. There are three primary classifications of material handling in robot applications: material transfer, machine tending, and palletizing. Material transfer is a process in which objects are moved from one location to another. All industries use material transfer devices of some kind. Machine tending consists of loading a part into a machine or removing the processed product. Some examples of machines that robots load and unload are CNC mills, CNC lathes, and injection molding machines. Palletizing is a process in which parts are placed into cartons for transport. Robots often load finished products as they come off the assembly line. Assembly is the application in which parts are placed together into a finished product. Assembly processes include fitting, fastening with screws, gluing, and welding. Finishing processes include trimming and deburring, painting, and applying coatings. Describe how robots are applied to CNC machine loading and give an advantage. Many industrial machines require that parts be placed into the machine and then removed after the machine is finished performing its operation. A CNC milling machine uses a computer-controlled cutting tool to remove material. Material processed in the milling machine is usually held in place by a device called a vise. The vise clamps the part firmly to the table of the machine so that it does not move. To make a part, the operator loads the part into the vise, clamps it, and presses the Start Push button on the machine. The CNC machine then performs a series of operations to machine the part. When the operation is complete, the operator unclamps the vise and removes the part. Then the cycle can be repeated. The CNC machine is a good application for robot loading and unloading because the task is repetitive. A detailed diagram of the devices that can be used in a robot or CNC work cell and how they are interfaced with each other is shown. In this application, the robot controller is interfaced to the CNC machine through a digital input and output module. The digital I/O module of a CNC machine is very similar to a robot. Another robot controller output directly controls the vise, which is electro-pneumatically operated. It should be noted that most larger CNC machines use a hydraulic vise. These are controlled by robots in the same manner as a pneumatic vise. An example of a robot CNC work cell operation is shown. A part arriving on the conveyor trips the part sensor and starts the cycle. The robot then picks up the part and places it in the vise. Next, the robot closes the vise by turning on its output, then releases the part and moves out of the way. Then the robot turns on another output to send a signal to start the mill. When the milling process is complete, the mill sends a done signal back to the robot's input. The robot grabs the finished part, opens the vise, and places the part in the parts bin. Define the work envelope of a robot. A robot's work envelope is the area where the robot operates. The work envelope is bound by the furthest locations that the robot can reach using its full range of motion. The robot can only position its end effector within the boundary of the work envelope. Within this boundary, the robot can position its end effector to any point. Therefore, any devices the robot must reach must be located within this envelope. Notice that the work envelope is measured at the faceplate of the wrist and not at the end of the gripper. This is because the end-of-arm tooling is interchangeable and these tools vary in size. Describe the work envelope of a double-jointed robot and give an advantage. Some robots are designed to flip over to reach the area directly behind it. To do this, axis 2 and axis 3 of the robot must have a larger range of motion than the other axes. This is called a double-jointed design. There are three advantages of the double-jointed design over a single-joint design: larger work cell area, tight space navigation, and quicker work envelope travel time. The robot can service a larger work cell area. The robot can retract its arm from tight spaces without rotating its waist. This is extremely helpful in machine tending. Less travel time is needed within the work envelope, so a faster work cycle can be achieved. Describe the four types of robot geometry and give an advantage of each. In order to match a specific application efficiently, Robot body axes can be arranged in different rotational and straight-line configurations to perform better. These configurations are called the geometry of the robot. There are four main types of robot geometries: Cartesian, cylindrical, polar or spherical, and revolute or articulated. The three axes of a robot having Cartesian coordinate geometry are capable of only straight or linear motion. The work envelope is box-shaped. Points within the envelope use a system of coordinates x, y, z that correspond to the position of each robot axis. For example, one corner of the envelope having the coordinates 0, 0, 0 would represent the fully retracted position of each of the robot's axes. Another point having the coordinates 6, 6, 6 would represent the point at which each of the axes were extended by 6 inches. A Cartesian coordinate robot called a gantry robot is mounted overhead in order to save space. The Cartesian coordinate robot is excellent in applications where horizontal and vertical moves need to be made with high accuracy and repeatability. Cartesian coordinate robots are also used to assemble small parts or insert parts into electronics printed circuit boards with a minimum of robot programming. Robots using cylindrical coordinate geometry combine straight line and rotational movements. Usually this machine has one rotational axis and two straight line or linear movements. Together, these three movements produce a cylinder-shaped work envelope for the robot. These robots are primarily used to perform pick-and-place operations such as loading or unloading palletized materials to and from conveyor belts. The geometry design of this robot is very efficient, and the robot is relatively easy to program. The polar or spherical robot's geometry has two axes that are rotational, the waist and shoulder, and a third axis that is linear. The robot's work envelope is spherical shaped. The advantages of the polar geometry are simplicity of design and good lifting capabilities. This type of robot configuration is used where a small amount of vertical movement is required, such as loading and unloading a punch press. The revolute, or articulated configuration, describes a robot with joints and movements that resemble the movements of a human joint. The revolute robot has great flexibility and can perform complex movements within its work area. This type of geometry makes a robot suitable for applications such as spray painting and welding. Horizontal revolute configuration robots are also called SCARA robots. SCARA means Selective Compliance Assembly Robot Arm. These robots are especially designed for assembly applications. SCARA robots traditionally have several rotational axes in a plane parallel to the work surface and one axis in a vertical plane. Describe 6 steps used to develop a robot program for a given application. As robot applications get more complex, it is very important to use a step-by-step approach when designing robot programs. This approach makes it easier to write the program. It also provides the documentation to aid in changing the program later if needed. There are 6 steps to design a robot program. Step 1. Create a pictorial diagram. Step 2. Create a general sequence of operations. Step 3. List the inputs and outputs. Step 4. Create a detailed sequence of operations. Step 5. Create a list of points. And Step 6. Write the program. Workcell drawings usually include an overhead view that shows the robot, the devices it will interact with, the location and type of input and output devices used, and the parts to be handled. The drawing should be drawn to scale, or at least with accurate proportions. The general sequence of operations is a general overview of how the robot will perform its task. This is a broad overview of steps the robot will perform to accomplish the task. The input and output list should include the name, function, and type of I/O devices needed for this application, as well as the I/O address for each device. The detailed sequence of operations lists every step-by-step action or communication that takes place for the robot to perform the task. This is actually a refinement of the general sequence of operations. This is a list of points where the robot must move to achieve the detailed sequence of operations. The function of each point should also be described. The point list enables the programmer to teach the points quickly and then refer to them later. Once steps 1 through 5 have been completed, the program can then be written. The program can usually be developed by writing a program command for each step in the detailed sequence of operations. This detailed sequence of operations becomes the comments that explain each command in the program. Define material transfer and describe 5 methods. Material transfer is a process where objects are moved from one location to another. All industries use material transfer devices of some kind. Human, robot, forklift, automated guided vehicle or AGV, and conveyor. People are most often used to transfer light loads over short distances. The advantages of human material transport are flexibility and low initial cost. Robots are also used to transfer light loads over short distances within the robot's work envelope. The robot can do this at a lower overall cost than a human because it can work 24 hours a day. Forklifts are manually operated, truck-like devices used to transfer heavier loads over longer distances than either people or robots. Forklifts are the most flexible method of material transfer because they can carry heavy loads anywhere in the plant and don't take up much room. But because a person must operate the forklift, they are the most expensive method of long-distance transfer. Automated guided vehicles are like automated forklifts. AGVs cost less to operate than forklifts because they transport material along predetermined paths and, therefore, do not need a human operator. However, AGVs are less flexible than forklifts because a program change is necessary to change its path. Conveyors are stationary, motor-driven machines that transfer material continuously over fixed paths using electric motors and a belt. For material transfer over long distances within a factory, conveyors are the lowest cost method. Conveyors are the least flexible because they require a lot of room and may block pathways. In order to change the path of a conveyor, the Describe 3 conveyor applications. There are 3 common applications for conveyors. Transport of raw materials to processing stations. Transport of partially finished products between the workstations of a factory. Transport of finished products to their storage location. Raw materials are brought to the processing station. An example would be a conveyor carrying iron ore into a steel manufacturing process for the purpose of extracting the iron. The conveyor transports the workpieces along an assembly line to each workstation to install parts. An example of this would be an assembly line that produces cars. The car is moved on a conveyor from one station that installs the glass to another that installs the tires. The conveyor transports the finished materials to their final location. An example would be the movement of cases of cookies to a stockroom where they await delivery. Describe two. There are two basic types of conveyors: bulk material conveyor and pallet transfer line. The bulk material conveyor is the most common type of conveyor. This conveyor simply moves materials from one location to another when a high degree of precision is not necessary. The most common type of bulk material conveyor is the belt conveyor. The belt conveyor uses an endless belt powered by a drum or roller at one or both ends of the conveyor. The middle of the conveyor can be supported by either a flatbed or rollers. Bulk material conveyors are often used with manual operator stations where people lift, sort, assemble, or perform some other task. The pallet transfer line is a type of conveyor that transports parts or assemblies on a pallet. The pallet rides on a conveyor. Then, the pallets are stopped at each workstation or removed from the conveyor completely. Pallet transfer lines transport material between stations. The pallet transfer line usually transports partially finished or finished products. Here are some common applications for bulk material conveyors. Transport of raw material to processing stations. Transport between workstations. And transport of finished products to their storage locations. By using bulk material conveyors, large quantities of raw material such as sand, iron ore, or coal can be transported. Bulk conveyors are used to transport materials between workstations only when the parts do not need to be precisely located. Bulk material conveyors are used to transport finished products from the manufacturing process to a warehouse or a truck. There are two common applications for pallet transfer lines. Transport materials that do not travel well, and transport partially finished products between workstations. Pallet transfer lines are sometimes used for the transport of items that do not travel well on a bulk material conveyor because they may be lost or damaged. Examples of typical palleted products include clothing, nuts, and bolts. Pallet transfer lines are more commonly found transporting partially finished products between workstations. These workstations can have either manual or automated processes. Pallet transfer lines are used in manual assembly processes because pallets serve as stable platforms on which to assemble parts. Pallet transfer lines are used in automated assembly processes because the pallet accurately positions the parts so that a robot can find them when the pallet stops at the robot station. Describe the operation of the external motor commands M on and M off. The MCL language includes commands that allow the robot to control a conveyor. M on and M off. The M on and M off commands complement each other and are used together not only to control conveyors, but also any other motor that only needs to be turned on or off. The M on command will turn on a motor that is attached to a robot controller axis. The first number defines the direction that the motor will turn. A positive number causes the motor to turn forward. A negative number causes the motor to turn in reverse. The second number is the axis to which the conveyor is connected. In this example, the conveyor motor attached to axis 7 would turn on, causing the conveyor belt to travel away from the conveyor motor. In this example, a conveyor motor attached to axis 8 would turn on, causing the conveyor belt to travel toward the conveyor motor. Once the conveyor has been set in motion with the M on command, the M off command is used to turn the motor off. The M off command is followed by only one number. This number is the axis to which the motor is connected. Two examples of the M off command are shown here.